Good evening, everyone. This is BremSter, and tonight this is a bit of a celebration for me. I'm actually trying now to record the final puzzle for me to record in the Cagey Constraints Sudoku Pack. So I've set myself a goal of recording all of the puzzles submitted for the pack before I put the pack together, so I could get an idea of what to put the puzzles into. So this will probably not be the last puzzle in the video series, because I don't know what the difficulty is, but I doubt it's going to be the hardest puzzle. But for me, it's the last one to record, so this is a bit of a milestone for me. So let's have a look at Parted Killer by MavericksJD. So, normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Digits in cages must sum to the number in the top left corner of the cage, and digits may not repeat within cages. And digits on arrows sum to the number in the attached arrow circle. I did slightly change the color of this arrow to indicate that it's clear that these arrows cross. It's only a slight difference, but I thought it was pretty clear anyway. It's a standard thing that arrows sometimes do, but I thought I could make that one even more clear. I'm going to restart the puzzle to restart my timer. Let's give this a shot. Okay, so the first thing I can see is a 23 cage. The 3 cells, the maximum digits you can put in, because you can't repeat in a cage, is 7, 8, 9. They sum to 24. I have to reduce one of those digits by 1 to get down to 23. The only digit I can reduce without causing duplicates is the 7 to a 6. So this 23 cage also has to be 6, 8, 9. That gives me a 6, 8, 9 triple in the column, which is important because of 16 in 2 cells. You can do it with 9, 7. If I was to try and do it with an 8, I need 8 and 8, and then I hit 7, 9, and then it becomes impossible. So this is 7, 9, and the 6, 8, 9 makes that the 7 and that the 9. So that's all forced. Now, 15. Okay, I'm not sure if this is fully forced, but I can see I have to put a 7 into this, because a 3-cell 15 cage either is 4, 5, 6, or it has a high digit, a middle digit, and a low digit. High being 7, 8, 9, middle being 4, 5, 6, and low being 1, 2, 3. And the reason for that is you can't put 2 low digits into a 3-cell 15 cage, or you'd need a digit 10 or higher. You can't put 2 high digits into a 15 cage, or you've already hit the 15 or more. And if you put any 2 of the middle digits, 4, 5, 6 in, it automatically becomes all 3 middle digits. So it's either a low, a mid, and a high, or it's 4, 5, 6. But I can't make it 4, 5, 6. So this is a low, a mid, and a high, and the only high digit available is 7. So it's 7 and 2 digits that sum to 8. Now I can't use 1, 7, I can't use 2, 6. So this is actually 3, 5, 7. And these are 1, 2, 4, 5, 6, 7, 8, 9. So these are 1, 2, and 4. That's cool. Now, what else can I tell? No. Well, there's no 9 in those, so that's a 9, which takes the 9 out of those, making that the 9. And that 9 hits the 15 cage, because the 15 cage is either 9, 6, or 7, 8, and it's not 9, 6. So that's 7, 8, which makes that the 6 and that the 8. That's cool. Now, where do I get a restriction now? Well, I know the sum of those cells. So an entire box of a Sudoku contains all of the digits from 1 to 9. If you sum the digits 1 to 9, you get 45. So I know the entire sum of this box is going to be 45. Now, these sum to 16. If I add 9 to 16, I am at... If I add 9 to 16, I'm at... What's wrong with me? 25. If I add another 12, I'm at 37. So the sum of all of those cells is 37. So that has to be an 8 to get to the 45. Which means those have to sum to 11. But there's multiple ways of doing that. These are all from 1, 2, 3, 4, 5. But I don't think that's it. Eight in this box is in one of those 3. 9 is not, right, 9 is in one of those two, because this 9 is knocking 9 out of those, that 9 is knocking 9 out of those, and I can't put 9 in a 7 cage, so 9 is in one of those two. So 9 is not there, 9 is not there. Can I put 9 there? No, I can't put 9 there, so 9 is in one of those two. And the reason I can't put 9 there is if I put 9 there, those two cells would have to sum to 2, and there's no way of making two cells sum to 2. The minimum is 1 and 2 summing to 3. So 9 is in one of those two. Am I looking at arrows at this point? Maybe. Yeah, I am. Because in this column, where can I put the 9? I can't put it in those three cells because the 9 is down here. I can't put it here because of that 9. I can't put it here because of that 9. But there's another reason I couldn't put it here, which is I can't put 9 on any of these arrows because all of these arrows are at least 2 cells long. And with the arrows being 2 cells long, if I put 9 on the arrow, once you add another digit, the circle would have to be at least 10, but I can't put 10 in an arrow. So 9 is not here, 9 is not here or here, and no 9 can go on those. So that's the 9. That leaves 3 places for 9 in that box. And 3 places for 9 in that box. Now, is there anything about this? If this is 8, 9, that's a 2. If 9 is up here, it's with 3. I think that works. Because if this is 9, 3, this becomes 5, 7, and that becomes a 3, and that becomes a 3, which is fine for a 9 cage. What can this be? So the ways of making 12, you've got 9, 3, which I can do. I can't use 8, 4. 7, I can't use 7, 5, because if this was 7, 5, both of those would have to be 3, and this can't be 6, 6. So this is 3, 9. That's kind of cool, which means there's no 3 down here. That's 3. That's not the 9. That being a 3 pushes 3 into there. These have to sum to 6. So they're 1, 5 or 2, 4. And we know there's a 6 in this 12 cage with either the 1, 5 or the 2, 4 that isn't in here. Interesting. That digit's a maximum of 5, but I got that from the row. I was using a combination of row and column, and I didn't need to. Okay, so these have to sum to 11. I'm not using 9, 2. I'm not using 8, 3. I could use 7, 4 in that order, because the 7 looking up. I could use 6, 5, but only in that order, because again, the 5, 7 looking up. Well, hang on, 7 is in one of those 3. 8 is in one of those 3, but not there. 8 is in one of those 2. Don't think... There is a 5 up here. Oh, wait a minute. Where's 5 in this column? So this can't be 6, 5, because 5 in this column has to be up here. So this is the 7, and that's the 4, which means there's no 4 there. And these are 1, 2, and 6. So if this... I don't know that that's actually done much, because this still could be, if that was 6, this would be 1, 2, and that doesn't work. So this isn't the 6. The 6 is in here. So if this is 6, 1, that is 5, and if this is 6, 2, that is 4. This is a 4 or a 5 only. So this is a 1, 2, oh, right, this, wait a minute, 8 is up here, but this is a 1, 2, 4, 5. So 1, 2, 3, 4, 5. This is a 6, 8 pair. So these are 1, 2, and 5 for the box, making that the 4, taking 4 out of there. So 4 is in here. This is weird. Okay. If there's a 5 on this, hang on. That can't be a 5, surely. Hang on, what can this be? Because it can't be 8 or 9. So if it could be a 7, but after that it goes down to 5, 4. It can't be 3, or all of these would have to be 1. So this is 4, 5, or 7. But this is a 1, 2, 5. If I put a 5 on this, I could go 5, 1, 1, I think. So this still could be 7. But what's the maximum that could be? If this is 1, 2, the maximum that could be is 4. So this is 1, 2, or 3. Because if this is 1, hang on, how does that work? If that's 3, these would have to sum to 4, and they can't. This is just a 1 or a 2. I'm not sure. Sorry, I'm completely stumped here. I'm not sure what I'm looking at. So I can see these cells have the same sum as those cells, because those two cells have the same sum as that. Those two cells have the same sum as that. Those two cells have the same sum as that. The minimum this could sum to is 1, 2, 3, 4, 5, and 6, which is 21. So I have to get these up to at least 21. But with a 9 here, that means these have to sum to at least, what, 12? And that's easy to do, particularly considering that could be a 9. Well, in this row, 9 is in one of those two. So one of these arrows is a 9. No, that's not it. Okay, it's actually been several days since that edit point, and I was trying to decide, do I try and start recording this puzzle again, or do I keep my original reactions? And I think I'm going to keep my original reactions and try and pick up. So I watched the video and got to this point, which is just before I had to stop, and I started investigating something when I got interrupted, and literally I have not been able to return to any solving for a few days. So I'm now going to show you what I was investigating when I got interrupted. I thought rather than starting from scratch, it'd be better to do this. So where was I? So what I was looking at is 8 in this row. So I can't, if I put 8 into this row, 8 has to go in this row somewhere. Now, it's not on this arrow because of the limitations on this arrow, this being 4, 5, 7 because of what goes down here. So, yeah, it's not here, but, well, because of the 8 pointing up and everything. So, can it go into any of these 3 cells? Well, if I put 8 here, this would have to sum to 9, and it can't. But can I put 8 on here? Well, if I do, this becomes 8, 1, and this becomes a minimum of 2, 5, which means this would have to be a 0 to make that its maximum 7. So I can't put 8 anywhere here, and this becomes an 8, 9 pair. That's what I was investigating, and I hadn't found the 8, 9 pair yet. So now I'm completely blind. So I do have to put a 6 over here. I wonder if that's it. Does that mean this has to be 3, 6? Well, what are the other options? I can't use 1, 8. I can't use 2, 7. I can use 3, 6. I can't use 4, 5. These are 3, 6. So this isn't the 6. And because 1 has to be, or 1, 8 isn't available, 2, 7 isn't available, 4, 5 is available. This is 3, 6. So this is 1, 2, or 5, which I don't think real. Well, hang on. I can't not put a 1 here for the same reason I couldn't put an 8 here. There must be a 1 in one of those two cells, or this becomes 2, 5, and this total here is blown. So this can't be a 1. This is a 2 or a 5. But I don't know which. But this sums to 8 or 9. No, there's a lot of options here. There's a lot of options here. Like this 9 isn't 3, 6, but it's anything but 3, 6. Seven down here, maybe? Because can I put 7 in any of those? I can't put 7 in a 12 cage. This is quite low. Like this is 8 cells summing to 30. And I got that so quickly because 7 plus 11 is 18 and 18 plus 12. That's easy math. So 8 cells summing to 30. The minimum these can sum to is 21. If this is 19 and that's a 2. So these... Does that work? There's got to be at least a 6 in here somewhere. If this is 1, 2, 3, 4, 5... I think I have to put 1, 2, 3... Well, there's 1, 2, 3, 4, 5 down here. So there's 3, 4, 5 down here, which already sums to 12. So 5 of these cells have to sum to 18. That's not... So these are 1, 2, 3, 4, 5. Oh, man. So I've already seen that 9 can't go into these cages and 8 can only go into this one. If I put 7 down here, it's here. And then these would have to sum to 5. So they'd be 1, 4 or 2, 3. Which would take 1 and 2 out of here. This looks like it could be absolutely anything. It could be 1, 6, no problem. 2, 5 seems okay. 3, 4 is an interesting problem because 3, 4 is here. So if I put 3, 4 here, where do I put 3, 4 in box 7? So it can't be 3, 4. So it's 1, 6 or 2, 5. Are any of those a problem? If this is 2, 5, this is 1, 7. So that becomes 5. That becomes 5. This is 2, 5. This is 2. What are these? I don't know. How would I make that work? Because if this is 2, 5, the 7 here pushes 7 up here. So this becomes 7, 8, 9. That becomes 8. This becomes 7, 9. That becomes 6. So if this is 2, 5, that's 6. And these would need to sum to 6, which I couldn't do. Wow, that's a long chain. If this is 2, 5, that's 7, which pushes 7 up here. So this becomes 7, 8, 9. So 6 in this box, with this being 2, 5, has to go there. So these have to sum to 6, which would either be 1, 5, which it couldn't be because I put 2, 5 here, or 2, 4, which it couldn't be because I put 2 in here. So this can't be 2, 5. This is 1, 6, which makes that 2 and that 1, taking 1 out of all of those. Takes 1 out of those. So this is 2, 6, which is 8, meaning that's the 4. There's no 2 or 4 in here. This is 1, 5. Has that done so little? Okay, so what can these be? This is 1, 6 now. So how do I do the 12? Oh, the 1, 6 makes that the 8 and that the 6. So there's no 8 in here. So how do I make the 12? Do I need a 7? Is this 7, 9 now? Without 7, the maximum that could be would be 3, 4, and 5, which is 12. With a 7, I would need to make 5, which would be with 2 and 3. Is that right? Yeah. So if this is 7, that's a 2. If 7 is up here, this is 3, 4, 5. Hang on. No, with a 7, that's 2, 3. Hang on. That would be 4. So if this is a 7, this becomes 2, 3. Is this the way to do this? This feels weird. If this is a 7, this is forced to be 2, 3, because they're the minimum digits I've got, and they get me to 12. If this is 7, this is 2, 3. These are 4, 5, and 9. So this becomes 4, 5. Minimum here is 4, 5, and that would no, that doesn't work. Because if this is 7, these are 2, 3, these become 4, 5, and that would have to be 2, which it can't be. So that is not a 7. So this is 7, 9. So these were 2, 3, 4, 5. This is 2, 3, 4, 5. But how do I make 12 out of those? It's 3, 4, 5. That's the 2. There's no 2 there. These have to sum to 9, which is either 3, 6, which it can't be. So these are 4 and 5. And now, where do I put 5 in this row? I can't put 5 here because of the 4, 5 pair. I can't put 5 here. That's the 5. That's the 7, which I could have got from using the 7, 9 pair. That would have been an easier way of doing it. This is weird. 4, 5 looks up making that the 2, and now this is 2 higher than that. But these have to sum to at least 21. The 2 makes this 1 and that 5, which means this is 1 and 7. Which means that's a 2. 1 is now up here. So if that's a 1, that's a 7 or an 8. All of that seems possible. This was weird. Can I take that any further? Well, I know the 3 is in one of those two from row logic, so that can't be a 3. So I know what these two are. 1, 2, 3, 4, 5, 6, 7, 8. So this is a 3, 9 pair. So I know what these 3 are. 1, 2, 6. There's no 2 there. So there is a 2 on this arrow. Does that mean anything? Does that mean anything? 7 is in one of those two, but it can't be here because 7 plus 2 would be 9, and I can't make that 9 or higher. So 7 is in one of those two. So I can get that digit. I can absolutely get that digit because those digits sum to 17. Those, and I'm actually going to get rid of this colouring. These digits here sum to 17. Those digits and those digits are the same sums because that sums to that and that sums to that. So this is 17, this is 17. 17 plus 17 is 34, 35, 42, that's a 3. So that's a 9 and that's a 3. And these are made up of 2, 4, 5, 6. And I can't put the 5, so the 9 arrow is going to be 5, 4, because I can't put the 5 with the 3 to make 8. So there's going to be a 5, 4 on the 9 arrow. There's no 6 here. Right, so 3 in this column is right here, and that's a 4, 5, because I can't put the 3 there because of that. So this is 2, 4, 5. So 3 is in one of those two. So the 8 is going to be 2, 6, and the 9 is going to be 4, 5. There's no 2 here. So let's do that again. The 8 is going to be 2, 6. So if that's not 6, that can't be 2. If that's not 2, that can't be 6. So 6 is in one of those two. That's the 8, and that's the 6, which puts 8 up here. But this can't be a 1, so that can't be the 8. So now 8 is in... Oh, that's cool. Where is 8 in this column? This can't be 8, 1. So 8 can't go up here. 8 can't go down here. So 8 is in one of those two. But if that is an 8, it'd have to be 8, 1, 9. And that can't be a 9. So this actually is an 8. So these have to sum to 8. What is this quadruple? It's 1. It's not 2, 3, not 4, 5, 6, 7. 1, 3, 6, or 7. Now that's not a 7 because of that. So 7 is actually up here. Yeah, I can't put 7 in any of those. So 7 is on this arrow. So it either has to be 7, 1 or 7, 2, and it can't be 7, 2 because of that 2. This is 7, 1, or I could have taken 3, 6 off because of that. This is 7, 1, that's the 1, that's the 7, making that the 8 and that the 9. We've already determined the 9 must be the 4, 5, so this isn't the 2, this isn't the 6. This is the 6 because of the 6 looking up, that's the 2. Taking 2 out of there, this is a 4, 5, and now I'm done with this colouring. Now, do I want to reinstate this colouring? I don't think so. Now, there's no 1 in these, but this is now restricted. I don't need the colouring. I can just use the restriction because they're not, these aren't 1, 2, 3. They are 4, 5, 9. I can't put 9 on the arrow. The 4, 5 pair makes that the 9. And this is either 2, 4 for 6 or 2, 5 for 7. So this is a 6 or a 7. Now, 8 is either 1 plus 7, and it can't be, so this is not a 1. It's 3 plus 5 or 6 plus 2, and it can't be the 2. So this is the 5, 3. The 3, actually, I could have got that from this maybe. I could have got it from the column, I think, but I got it a different way. The 5 makes that the 1 and that the 5. Oh, the 6 has made that the 2 and that the 6 ages ago. I don't know that that would have helped me much. The 5 makes that the 4, which looks now making that the 5 and that the 4, which makes that the 5 and that the 4. The 6, of course, looks down, making that the 1 and that the 6. The 9 looks down, making that the 7 and that the 9. The 6 looks up, making that the 7, which makes this 2 plus 5, which makes that the 4 and that the 5. Now I'm doing all sorts of stuff in columns. I need a 1 in this column. These are 2, 3, and 8. There's a 2 and an 8 already. That's the 3. I take the 3 out of those. The 2 and the 8 is resolved by the 8, making that the 2 and that the 8. Now the 6 here, of course, takes the 6 out of here. So this is a 1-2 pair. So this has to be a 5 to complete the 8 total. So 1, 2, 3, 4, 5, 6. This is a 7. 7 plus 2 equals 9. 1, 2, 3, 4 is what I need for this part of the box. 1, 2, 3, 4. 1 and 6 go in. Now, this 9 looks down, making that the 3 and that the 9. The 3 looks up, making that the 6 and that the 3. The 6 looks down, making that the 1 and that the 6. The 1 looks down, making that the 2 and that the 1. I could have started with that 2 as well. The 7 looks down, making that the 8 and that the 7. These are a 4 and an 8, and I'll use that 4 to make that the 8, that the 4. And that is the solution to the puzzle. That is kind of nuts. This bit was weird. There's a lot of weirdness in this puzzle. I liked how you kept flitting backwards and forwards between the arrows and the cages, but this bit down here, that was tricky. I'm not sure I'm a huge fan of that chain. But what I am a huge fan of is I have now finished recording this pack. Now, yeah, I'm not going to talk about what I'm planning, the plans for the pack are, because I don't know where this is going to fall into the video series. So, yeah, thanks everyone for watching. And as always, good luck with your solving.